Hello, my name is Jesus Valdez. In today's presentation, we will be talking about a loan default analysis. So the agenda today is we will give an introduction as to why we are doing this pitch, the business problem, and why we are employed to make this model. Then we will talk about the data that we will be implementing. Once we have that data and we define that, we will prepare that data to go into model development, and we will show how we develop the predictive model for this assignment. And then once we have a model, we'll evaluate and make a decision on the right model, and then we'll apply it or have a deployment of that model, and then we will conclude. So in this analysis, we're going to create a predictive model. And this model is going to decide if a client, based on various information, will default on a loan that they were given and they took out. And we will be using logistic regression models and other types of models to identify the proper prediction and make an accurate prediction for this case. So the bank has had issues with clients defaulting on loans, and clients can default on various loans: mortgage, car notes, and personal loans. The actual loan category is not what matters as far as why are they defaulting, and is there a way for us to predict that based on information the bank has given us and different attributes on that. So we're going to take that information, and they're asking us if we can make a model to identify if a client prior to taking a loan out is going to default on that. So our objectives today is we're going to identify the data, define it, see what's relevant in that. We're going to input that data into RapidMiner and prepare it. And then we'll create a model that accurately predicts the default status. So the data that we were given from the bank is 2001 entries. Each client had 5 attributes with the information we were given. So the client ID is an ID number that is assigned to every client. There's no names given. The next one is income. Income is the annual earnings that the client has that we can identify if that was an issue with their loan default. And then age. Age is the age of the client. Is there any relevance to how old a person is? If there's a trending attribute there. And then loan. How much did they take out? Maybe the loan was too high for what they were making. And then default. This will identify if they did default on it, and we'll use this information to create a model. So data inspection. So as we got the data, we want to look at a few things. Number one, is the data accurate? So looking across the data here, we have the client ID, income, age, and loan. All of that should be numerical. And we're looking at that, and everything is. There's no numbers or letters in there that should not be there. They're all numbers. Is there any missing data or erroneous data? And so as we go into next slide, we realize that there was negative ages. So that could have been someone inputting the incorrect information. There's probably a typo of some sort, or missing. There's some missing ages right here. You see, looking at it, it was about 5 or 6. It wasn't that many. So in this case, what we decided to do is we remove the data prior to inputting it into the model. If we tried to use this data, it would inaccurately predict it. It would try to use a negative 52 age to determine. It would not be accurate to use this data. So we did remove that data prior to processing that. Now, once we got the data all figured out, we went into our data prep stage. So what we did is we took that Excel sheet and we created our own process within RapidMiner. We loaded it into there, and then you see at the bottom left-hand corner, that's the information came at here. You can see already that the age is 18 at the lowest, so there's no negative ages anymore. And then we had identified the binary prediction, and we started to set roles. So in this model, we need to make the a binary prediction. We need to decide which one we're going to use to be the predicted attribute. So in this case, we did use the default as our label. That's what we're trying to figure out. And then because the client ID is not part of the equation, we didn't want that number to impact any of the results. So we made that target role as ID. So they'll still be on there, but will not be part of the equation or the machine learning. And again, default is label. That's what we're looking for. That's our Y, our target. So down below, one of the things that we do have to do is looking at the model. We saw 1 and 0s were the yes or no for the default. We do need to make that to a binomial value. So that's what you're seeing down there. We did change that 1 and 0 to true or false so that we could have that, that prediction. So once we made all those corrections in there and identified that, you'll see right here that the client ID is now in blue, is not going to be a part of the equation or the process. And then default, we do have that target as our label. And then those values are no more 0 and 1. It's true or false. So we're ready to get that data prepped in, ready to go. So now we need to start to develop this model. Before we do that, we need to kind of allow the model to start learning and training. So what we did is we did a data split operator. So what that does is it takes part of the data for training, and then the other part we test that data against that training. So the ratio is up to the model, but what we did here is we took 0.7 of that data and partitioned it off to the training. And then the 0.3 is to test that training model to make sure it is accurate based on the information and the model that we give it. There are many different types of regressive models, decision trees. There are different types of models that we could use. So what we did here to accurately use the best possible predicting model is we use what we call a raw comparison. And what that does is we can use as many different models as we want and see which one is the likely more accurate or the likely accurate one that we would want to use for this model. So as you see, that is kind of the setup of my process at the top. Down below is the different models that I used to against each other to see what one was the right pick. So we used decision tree, random forest, logistic regression, and naive Bayes. So if you look over at that right side, that red one right there, that one is random forest. That one is a red line that went up pretty quickly from the beginning of the clients, and it steadily kept going, and it stayed true all the way through the top, as you can see up there. The bottom blue one is naive Bayes, and that one did not fare very well. So we'll see what we decided when we looked at the information. So we processed every single one and ran the process to see what the accuracy, and we'll talk a little more in depth in that, but I'm just going to kind of pinpoint a few things. Is looking at decision tree, it had a great accuracy altogether, depicting true and false. However, the key for now is to decide if the recall or that predicting true actually was true. So we're looking at that information right there. Looking at it, it's a 95.29%. Very good accuracy, but can we get it better? So we looked into a logistic regression model. That is something that I tried actually first, and it did have a good accuracy of 94, not as accurate as the decision tree, but that recall was pretty low, 82.35%. So obviously we would not use that one since it's not as accurate. The naive Bayes, as we already talked about, did not even come close. The accuracy was pretty good. The recall of 64.71%. Not even going to look at that one. Wasn't close. And then we have random tree. Random tree was slightly more accurate when it came to, or a certainty, I should say. The accuracy was 99.33, very accurate. And then, but again, we're going to that recall or that true. Did it predict true? And we had a 97.68% or 65% accuracy. So out of those 85 that went through, 83 were predicted correctly to be true, and we only missed 2 that were predicted false. So looking at decision tree, they had 4 that were falsely predicted, and we only had 2. So by deduction, we would use the random tree. So again, to kind of break this apart, looking at this, we have the 99.33% accuracy for random tree, and we had 85 that were true. And the prediction, though, they predicted 83 correctly and only missed 2. So that 97.65%, great accuracy. This is the model that we would use. Looking down at the confidence, we took a few of the members that had very similar attributes. With 100% confidence, something you could look at is that income. If you look at the income, they're very similar in that mid to low $60,000. The age of anything under 35 fell into that category, and then the loan amount. Loans over 85, around 85 or 80,000 up to 100,000, did predict true that they were going to default on that loan. And so, as we talked about importance of the attributes, that income being fairly low compared to the loan they're taking out, and that age seem to be great indicators in using for this model. And this is kind of how the random tree works. It will look, hey, anyone greater than 34, almost 35, we're almost automatically going to pay their loan based on the information we were given and implementing about. Now, when people were under 35, 34, that age frame, it started looking at how much loan did they give out. If it was greater than 32,000, there was a higher chance that it could be. Anything under, lower, but there were other factors in based on how much a person made would determine if it was not high enough to pay that loan. So that's kind of how the random forest works, breaks all those attributes and puts them down for us to predict that model. So we'd utilize the same metrics, age, income, loan amount. We would need to do a quarterly review. So any defaults on the loans, I think every quarter we should run it through this model and make sure it's still predicting correctly. After that year trial, we could implement the model if it kept the accuracy the same based on that. And if we need to, we could add some attributes. We could do credit scores or any past defaults. Those could be implemented to help be a deciding factor. Some of the pros, we have an accurate model that determines the default rate or prediction of someone's going to default. And then we can avoid having those high default loans. Great thing about that is it's never good business for the bank to loan out to people that won't be able to pay it. It's not a good business. It does not help. Now, some of the cons that we should look at, make sure that we're practicing ethical values, is that we're not just basing it off of age and income. Many families do pay their loans even though they may have lower incomes or they're younger. We want to make sure that just because someone comes in that's young that there's an automatic no. We want to make sure that those other factors are being implemented, their income and the loan amounts, before we make that decision. And this would be something that always needs to be reevaluated so we do not fall into those issues. So in conclusion, the model gives us a great 97.65% certainty rate that we would identify if a client is going to default on those loans. This model meets the requirement from the lender that they may accurately determine the probability of the default.